Hey everyone, welcome to the Foundry by Forge College. I'm so absolutely thrilled to be here with you today for this explainer on deploying Anchor programs to a Solana cluster. You can really think of today as launch day. We've spent plenty of time in the hangar, right? Writing code, compiling our binaries, building out our smart contracts. But now, it's time for the real deal. It is time to put that code onto a cluster where it can actually be executed and interacted with. So we're going to cover how to perform a perfectly controlled deployment, verify that your deployed program is exactly what you expect, and validate its post-deployment behavior so there are absolutely no nasty surprises once it's out in the wild. Now, if you recall from our previous lesson on debugging tools, we really hammered home the importance of fixing test failures. And, well, there is a very good reason we placed that lesson right before this one. To put it bluntly, deployment compounds mistakes. Seriously, a broken program with unhandled edge cases or failing tests will absolutely still run on a cluster, but it's just going to amplify those errors in orbit, producing completely unpredictable behavior for whoever calls it. It's like launching a rocket with a flashing engine warning light. You just don't do it. We only ever deploy after our tests pass, just to guarantee that predictable, reliable behavior. Okay, let's dive into this. Here's our engineering blueprint for today's launch sequence. First, the pre-flight checklist. Second, setting up the environment. Third, executing the deployment. Fourth, verifying post-deploy behavior. And finally, documenting the transaction demo. Let's transition right into phase one, the pre-flight checklist. So a successful deployment isn't just about mashing the enter key and hoping for the best, right? We have to follow a strict, repeatable protocol. First, we build our artifact. That means making sure our unit and integration tests are passing, and we have a fresh compiled .so file. Then we deploy the program. And finally, we verify the result. Those passing tests are quite literally our cleared engine checks. If they fail, honestly, you don't even look at step one here. You go right back, debug, and fix them. Now, what's really interesting about this slide is our absolute best friend in this process, the solana-test-validator. Think of this little tool as our local, highly controlled launchpad. It allows us to spin up a local validator node directly from the command line. We use this to safely test, deploy, and debug our programs before we ever interact with the public main cluster. All right, with our pre-flight checks complete, let's move to section 2, setting up the environment. So you have to actively decide which cluster you're actually deploying to. And this brilliantly illustrates the stakes here. Over on the left, we have localnet. This is our safe sandbox. It's incredibly fast, totally private, and has zero fees. On the right, devnet and mainnet introduce public variables, network latency, and, real financial costs. You should always prefer your localnet or devnet for routine testing. In fact, 0 is exactly the amount of real-world financial consequences you face when you deploy your program on localnet, which is just incredibly freeing. I mean, if you deploy a bug or accidentally run an infinite loop, it costs you literally $0 real. It's the ultimate developer anxiety relief tool. Take full advantage of it while you get your footing. But here's the crucial point. You have to make sure your wallet is actually configured to interact with the cluster. Anchor uses your default solana-cli key pair, which is located at that path right there unless you specify otherwise. If your key pair isn't configured, or you lack test SOL, your deployment is permanently grounded. It won't even attempt to take off. Oh, and always record which key pair you are using for your deployment notes. That's a pro tip. Okay, the environment is set. It is officially time for liftoff. Section 3, executing the deployment. For execution, you actually have two distinct flight paths. Option A is the Anchor Managed Deploy. Typing Anchor Deploy lets the framework handle the heavy lifting, which is fantastic for simple flows. Then there's Option B, which is taking explicit manual control using Solana Program Deploy from the CLI, pointing directly to your compiled binary. This is incredibly useful for deterministic releases or when you need to pin down specific deployment parameters. Let's walk through this engineering schematic together. When we execute these commands, we expect some very specific outcomes. Anchor build gets us our compiled binary and our interface definition language, or IDL. Anchor deploy yields our deployed program ID and a transaction signature. And finally, a TypeScript initialization call gives us a final confirmation signature. Tracking these exact outcomes is totally non-negotiable if you want a reproducible run. Now, here is where a lot of beginner developers get tripped up. Your terminal spits back a success message. The command worked, the bits were sent. But did it actually work the way you intended?
Just because the command succeeded doesn't mean your smart contract is functioning properly in orbit. We have to actually prove it. And that brings us to Section 4, verifying post-deploy behavior. This is our crucial orbital readback phase. So let's dive into this. Here is our unbreakable 3-step verification protocol. Step 1, confirm your program ID and binary match expectations using Solana program show. Step 2, execute a basic transaction to initialize the program targeting that newly deployed ID. Step 3, verify the state changes. Basically, fetch the account data back and assert that the values are exactly what you expect them to be.
Now, occasionally you're going to stare at your terminal and see something terrifying, like account already in use or program account data mismatch. When this happens, please don't panic. It usually just means an outdated IDL, maybe a mismatched account address, or you're simply using the wrong wallet. Just stop, take a deep breath, inspect your program ID, and iterate tightly. Revert to local tests, fix the mismatch, rebuild, and try it again. All right, with a successful readback, we move to our final step, documenting the transaction demo. Look, science is only science if it's reproducible, right? So gather all these artifacts into a single text file or markdown note. We want the exact CLI commands, the deployed program ID, transaction signatures, cluster URL, key pair, and that fetched account data. Assembling this record proves a release is deterministic, and honestly, it elevates you from a tinker to a professional engineer. So you have successfully deployed, verified, and documented your Anchor program. It works flawlessly. But I want to leave you with this provocative thought. How much compute is it eating up, and how much is it costing you to run? Answering that question is the gateway to our next module on gas optimization and tightening instruction logic. I highly encourage you to head over to forge.college to continue your learning journey, explore those optimization techniques, and dive deeper into more Web3 topics. Thanks so much for joining me on this explainer, and happy deploying.